In this video, I am going to explain the concepts of generator matrix and parity check matrix of the linear block quotes. First one is generator matrix. Representation. Generator matrix representation of linear block quotes. In an n comma k linear block quote, define a code vector x comma message vector m and parity check vector C as follows. Encoded code vector capital X is equal to x1 comma x2 and so on xn. Message vector capital M is equal to m1 m2 mk. Parity check vector c1 c2 up to cq, where q is called as q is equal to n minus k parity check bits. Number of parity check bits. Here x can be written as generally x is equal to x1 comma x2 comma x3 and so on xn, x1 comma x2 comma xk, xk plus 1, xk plus 2 and so on xn. In a systematic form of linear block quotes, first message bits are appeared and then followed by parity check bits m1 m2 and so on mk, c1 comma c2 and so on cq. In systematic form, first are message bits or information bits and parity check bits. Definition of systematic form. In systematic form, the first k bits are the first k bits are the message bits. and the last n minus k bits are parity check bits formed by linear combination of linear combination of message bits. Okay, M1, M2, and so on up to MK are the message bits. In systematic form, the first K bits are the message bits. Okay. Next, the last n minus k, that is equal q is equal to, here q is equal to n minus k. The last n minus k bits are parity check bits formed by linear combination of message bits. Next one, here x is equal to x1 comma x2 and so on xn, and also x1 comma x2 and so on xk comma xk plus 1 comma xk plus 2 and so on xn is equal to, in systematic form, m1 m2 first message bits are appeared first, and c1 c2 and cq are the parity check bits. The first k bits of the encoded code word are message bits. Here the first k bits, here the first k bits, means from x1 to xk are the message bits. The last n minus k bits are the parity bits. Okay, comparing these two, that is equal to x1 is equal to m1, x2 is equal to m2 and so on, xk is equal to mk. The first k bits of the encoded code word are the first k bits of the encoded code word of x are the message bits. X is the encoded code word. First k bits of the encoded code word means from x1 to xk are the message bits m1, m2 and mk. Equating these two, x1 is equal to m1, x2 is equal to m2, xk is equal to mk. The last n minus k bits are the parity bits. That means xk plus 1, xk plus 2 and so on is equal to c1, c2 and cq. Here x k plus 1, x k plus 2 and so on xn. These are the last bits. The last n minus k bits are the parity bits. Parity bits means c1 is equal to c2 is equal to and cq. One more important point here is that the parity check bits are formed by the parity check bits are formed by linear combination of message bits. Linear combination of message bits means that is equal to message vector m is equal to m1, m2 and so on mk. Generally here x is equal to m by c. Here m is equal to m1, m2 and so on. mk c is equal to c1, c2 and cq. First xk plus 1 means linear combination of message bits means m1 exclusive r with m2 exclusive r with and mk. Here some coefficients are multiplied with m1, m2 and mk. These coefficients are like that. P here um, message bits are range from 1 to k. Here P1, P2 and pk. Next one is here C1. C1 is the first parity check bit, that is here mentioned 1, 1, 1. In this way, you have to frame the linear combinations. Here again m1 exclusive r with m2 exclusive r with and so on mk. Again coefficients are multiplied here. Here coefficients are multiplied here. Coefficients. Again messages are ranged from m1 to mk. Here p1, p2 and pk. Here second parity check bits c2, p2, here 2, here 2. And finally CQ is equal to xn. CQn where n is equal to the last bits is range from xk plus 1, xk plus 2 to x of n are the parity bits. Here again m1 exclusive r, m2 exclusive r, here mk. Here m range is from 1 to up to k. Here q is the last check bit, CQ, PTQQ and PKQ. These are parity bits. Parity bits. That means the last parity bits are nothing but the last n minus k bits of the code word capital X. The parity bits. Convert this into from x1 to CQ. Convert this into matrix form. Here x1, x2, xk, xk plus 1, xk and up to xn. First write down this one. x1, x2 and so on. xk, xk plus 1, xk plus 2 and so on. xn is equal to message vectors are message m1, m2 up to mk and some linear combinations that will be represented here. Here M1, comma M2 up to MK into here some identity matrix. Here some identity matrix here 1 0 0 0 1 0 0 0 and also there the P11, P11, P21, PK1. Here write down this argent. These are the P11, P21 and the PK1 are the coefficients of that C1. P12, P22, PK2 are the coefficients of C2 like that. Here P11, P21 and the PK1 here and P12, P22 and so on PK2. P1Q here, P1Q, P1Q, P2Q here, P1Q, P2Q and so on PKQ. These equations are converted into some form like that, matrix form. Here x1, x2, xk, xk plus 1, xk plus 2 up to x1. Representation is like that. Here m1, m2, mk. Multiply this first. This is the row. K rows are there. One cross k. One row is there. This one row is multiplied with the first column of this matrix. That means m1 into 1. That is equal to x1. Therefore, x1 is equal to m1. x2 is equal to m1 into 0. M2 into 1 and so on mk into 0. That means m2. x2 is equal to m2 like that. By multiplying m1, m2, mk row with this matrix, we will get all these expressions. Convert this equations into matrix form. Okay, next. This one is the identity matrix, IK, and parity matrix, parity submatrix. One is K cross Q. Parity submatrix is represented by K cross Q. The above one is represented as like that. Here X is equal to code word vector, encoded code word vector capital X, 1 cross n dimension. Here next one is this one completed. This one is the message vector capital M, 1 cross K. This one is the G K cross N, where G is called as a generator matrix of that linear block code. New matrix is introduced. That is G. Here G is equal to G is the K cross N, IK, P KQ, K cross N, where IK is called as identity matrix. where Ik is called as the identity matrix. And the P matrix is called as a, this one is K cross Q. P matrix is K cross Q. P matrix is the parity submatrix. Parity submatrix of order K cross Q, where K is called as the identity matrix and P matrix is the parity submatrix of order K cross Q. Generator matrix. The code words of the importance of this generator matrix is the code words of the linear block codes. That means 2 power k distinct n-bit code word. The code words of the linear block codes, that is 2 power k distinct n-bit code words are the linear combinations of the rows of the generator matrix. Suppose this generator matrix of order k cross n, that means k rows and n columns. The generator matrix consists of k rows, row 1, row 2 up to row k. These rows are nothing but the code words of the linear block codes. The rows are nothing but the linear combination of these rows of the generator matrix are nothing but the code words of the linear block codes. Next, another one is parity check matrix. Parity check matrix. It is represented by capital H. Here capital H is equal to dimensions of that capital H is Q cross N. P transpose, P submatrix obtained in previous derivation, and transfer that P matrix, and IQ identity matrix with the order is Q, that is Q cross N. Here P matrix of order is K cross Q. P transpose means P transpose matrix is Q cross K. These are the two important matrices. Which are very, very useful to analyze the linear block code performance, generator matrix and parity check matrix. Generator matrix, the name it's having some rows and columns, k rows and n columns, k rows and n columns. These rows are nothing but the linear combination of the rows of the generator matrix are nothing but the code words of the linear block codes. And the parity check matrix, one more matrix I have to define here is HQ cross N is equal to P transpose into P transpose by IQ, where IQ is the identity matrix. Identity matrix. P matrix of order is K cross K. Okay. These are the two important matrix: generator matrix G, and parity check matrix H. Okay. With this analysis of generator matrix and the parity check matrix of the linear block code completed. Okay. If you like this video, please subscribe the channel for further updates. Thank you.